My name is Thallis Pessi. I am now a second year PhD student at Universidad Diego Portales, and I applied for the PhD at UDP mostly because I found the research very interesting. What are the types of stars that generates the different types of transients that we detect? So how can we relate the progenitor stars to the different supernova types? This paper, it describes this event called 2011 FH. This was a very interesting event because it is part of this class of transients called supernova imposters. They are called imposters because they are not real supernova, but they are misclassified as a supernova. So in this image, we have the discovery image of 2011 FH near this spiral galaxy. An interesting fact about this event is that it was discovered by an amateur astronomer. So this image is from a backyard telescope. We also see some images before the event that were taken in 2010, where we don't see the bright explosion here. And we have this image after the event in 2013 that was taken by a larger telescope, where we see that the event is getting fainter with time. The amount of data that was available for the source, a big part of the optical observations were obtained by amateur astronomers in collaboration with my advisor, so who reduced and worked in the images. Another part of data was obtained by a survey using professional telescopes, such as the Catalina Real-Time Survey and the Carnegie Supernova Project. So the orange dots that we see here, they are the observations made in R-band. We have observations covering 10 years from 2007 to 2017. The star was slowly getting brighter and brighter, and then it culminated in this explosion of August of 2011. And also after the explosion, we can identify these bumps in the light curve. Was observed again by the Hubble Space Telescope 5 years after the explosion of 2011 on 2016. And it was very surprising to see that the source was still there and that it was still very bright. Our main conclusions of this work is that the progenitor of 2011 FH was a very young star and also a very massive star that could have possibly been a luminous blue variable. I will use data from the Very Large Telescope to try to make these connections between different types of core collapse supernovae and the environment around them. So I'm very excited because this is a very modern and interesting instrument, the MUSE instrument. I didn't like to work at home. I always like to have like a space to work, so to go to the university and have my desk so I could concentrate. Also, when you can knock at the door of your advisor, it makes things much easier. I'm very excited now because I will finally meet people from UDP and meet the professors, my advisor, the other students. I guess that will be very exciting. I'll finally be able to have a desk again, to have an office